Here's your chance for a little extra distinction. You've seen this in class. I'm not going to explain it to you. Just going to say these are all 4x4 squares. And the origin is here, x-axis, y-axis. Okay. So first of all, what's the formula for the function that we have here? I bet you can write that down real quick. If you can't, it's okay. We're going to be talking a lot about algebra this time, and we'll be sure. Okay. Now, then I want you to see if you can estimate y for x equals 13. And that would be a good thing in itself, although I should kind of be able to expect you to do that. Okay. And for 8 less than or equal to y less than or equal to 12. Now, if you give me any valid estimate of y for x equals 13, not bad, okay? If you give me an estimate for y and x equals 13 that's between 8 and 12, that's even better. Then the gold star question, if g of x is the corresponding function, in other words, the function here, there are 16 functions, about 12 functions here. 3 times 4 is 12. Okay. 12 functions here. This one, this one, this one, this one. Each one is a different function. Okay. If g of x is the one that you use to make this estimate, what's the formula for that function? Now, theoretically, everybody would know that from last time. That's a big stretch. Okay. I wouldn't expect that at this time without reinforcing it. But I'm just seeing if anybody's proactive enough. Between Tuesday and Thursday, it's unlikely. Short time. But see if anybody was able to do that, able to understand that. Okay. Now, estimate y for x equals something. Oh yeah, the formula for this function. Not sure people were writing that down. Okay, that formula would be y equals x squared. So I'm kind of assuming people knew that. If you didn't, make sure you do. Okay, now over here, okay, here's x equals 13. Here's 0, 4, 8, 12. Halfway to 14 is 13. There's 13. Some people had it over here. Some people even had it over here. I kind of forgave that because if I'd given you time to write everything out and label everything, you would have been okay with it. I want to see a vertical line, not through one of the dots in the piece. So, okay, an honest estimate of the y. Here's 8. Here's 0, 4, 8. And here would be 5. So I say y equals about 1.6. 8 plus 1.6 equals 9.6. We know from our constructed graph accurate graph, we say y equals 9, because if you move over 1 unit on your basic scoring function, which everybody pretty much drew correctly, you got to go up 1 unit, right? Over 1 up 1. Of course, that's because 1 squared is 1. There's your formula. Okay, so that's good. Now the formula, and I'm just going to write this down without much comment. Yeah, maybe. That's 2, that's 4, 8, 12. The x minus 12 squared plus 8. Now check it out. Plug in x equals 13 and do this. Okay, so what I asked you to do was plug in x equals 13 here and see that you really do get 9. We see geometrically why you should get 9 because you know how to construct this, and you know you got to move over 1 and up 1 from the vertex. And when you do that, you're going to get 9 because the vertex is at y equals 8. Everybody knows that, and you know I'm favorably impressed by what I'm seeing. Okay. Now, I'm going to actually use function notation here just because we got to get used to this. How many people had never seen function notation before I did it in class last demonstration? Everybody seen it in f of x type stuff? You certainly should have, and I would expect you have. Unless, like some people do, you completed a pre-algebra course and decided you were ready for pre-calculus. Okay, people can actually do that. You don't have placement testing anymore. Be sure. Badly written that says y equals f of x. Okay, and that was kind of glued in there with parentheses. So y equals f of 13 is 13 minus 12 squared plus 8. And of course, not everybody can subtract 12 from 13 and get 1. Square 1, you get 1, you add it to 8, and you just say it equals 9. Well, you miss a point if you do that. Maybe you didn't miss a point. Officially, you'd have to write this equals 1 plus 8, which equals 9. And you know what 1 squared is. So we'll accept this much of a shortcut. Okay. Now the reason, what's the significance of this 1? This 1 is how far you got to go up if you move over a unit. Okay. Try another one. You can see from the graph what f of 14 is. And you know what? I call this f of x. So I'm going to make a correction. It's g of x. It says the function is g of x, right? Anyhow. Okay, write this up. It's the same detail I did here. And think about what you get. Say it again, okay. Y equals g of 14, 14 minus 12, quantity squared plus 8, 2 squared plus 8, 4 plus 8, 4. What's the significance? 2 is how far we move over from this point, and 4 is how far we go up from this point. Y coordinate starts at 8, we move over 2 and up 4. Okay, the y coordinate is now 12. Okay. Okay, now what I'm saying is there are these things called transformations. Okay, people are doing a really nice job now with constructing these graphs without doing any arithmetic. Now we're starting to do some arithmetic in the plane because I want you to get real familiar with the plane and what it means to move around in the plane and stuff like that. Okay. The reason is we have transformations, and it's something that I've never seen a pre-calculus learn well. Calculus class learned mine, anybody else's that I've ever seen. And I score the assessments on all the pre-calculus classes. Okay. Then somebody else goes back and scores them too to make sure we're staying honest. Okay. By honest, I mean we're being consistent with what we did last year and next year. Okay. And we're consistent on ourselves. Okay, well, that's a different story. But I see the results of a lot of pre-calculus classes. And I don't see that people understand transformations, even though it's in the textbook in the first chapter. Okay, so this is all so you can understand transformations. And right there is the equation for the formula for transformation. Okay. Everything, almost everything in pre-calculus and calculus, and even beyond calculus, is built on these functions. These three, and then a couple more that are very much like them. Okay. So if I want to do this function, I'm not going to take the time to circulate around and see what everybody's written down, but write it down. Write down the formula for this function. I'm going to ask you to do some of this homework. Purple. Okay, how many do you think you have? Okay. Give you a hint. This point here is the point. What do we got? We've got 4, 8, 12. Oh, wait a minute. That's screwed up. It doesn't work. Question whether I did something really ignorant. Okay, for our blue graph. Blue graph. Okay, you move the graph over 12 and up 8, we got g of x equals x minus 12 squared plus 8, and it works. Okay, we checked it out for a couple of points. The formula works. Not something came down off a stone tablet. It works, and you can understand why it works. Because of what you get when you subtract 12 from any of the coordinates, okay? As we explained, you really want to understand that. You want to think about that. Otherwise, you've got a formula that you're going to forget as soon as you take a test, if not during the test. And you don't have a good way to rescue yourself if you forget that formula. Also, your thinking isn't as deep as if you understand the reason behind things. Okay, and the more deeply you can think, the more benefit you're going to have, not just in math courses, but in other courses and in life. So you can just think deeply. So it's a good idea. If you don't think it's a good idea, then just memorize a bunch of formulas. You're going to do some of that anyway, just out of desperation. You don't have 30 hours a week to spend on this course, but try to understand the principles because it's a lot easier than understanding a bunch of details. Okay, well, purple graph. Move over 4, up 4. So let's call this graph h of x. Okay. You got to subtract 4 from the x value because that's going to tell you how you move the dot. You got to add 4 because everything's 4 units higher. Now here's a rule for any graph, for any function. Can you read that? Yeah, let me write it. I'd like to get it in with all that. That's not gonna happen. Okay, so my starter's right. Move the graph over h up k. Okay. The equation becomes y equals g of x equals f of x minus h plus k. The rule says y is going to equal g of x, which is f of x minus h plus k. Got a question, you know? Okay, good question. Common misconception about function notation. This is what we've got. This doesn't change. If we move h units, k units, it doesn't matter what the function is at this point. This is the expression, okay? Now, at this point, this will answer your question. Now f of x is x squared, right? So what is f of x minus h? I'll write this kind of. If f of x equals x squared, what's f of x minus h equal? Okay, well, as I just said previously, everything's extemporaneous. We have to understand function notation a little better than usually comes out of a good algebra, even a good algebra 2 course, okay? So let's see, we got f of x equals x squared. Okay. Fill me with your fingers. What's f of 3? None. Everybody knows that, I think. Okay, just to be sure. What do? Yeah, f of 3, we've replaced x by 3. If we replace x by 3 here, we better replace it here. That's all it is. That's all function notation tells us, at least the mechanics of substitute. If we replaced x by 3, we replace x by 3. Of course, 3 squared is 9, right? Okay, now my favorite. We go right to the dictionary and open it, and the first word we see is aardvark. So what is f of aardvark? And I'm gonna, because people love to say it. Okay, so what's f of aardvark? Well, x has been replaced by aardvark, so we got to replace x by aardvark. We worry about what it means later. And that's the one we can worry about a whole lot. You can ponder that for the rest of your life. What's aardvark squared mean? Okay. I don't have a good answer. I mean, aardvarks aren't square in the first place. Okay. Make sense? Well, no, that doesn't make sense, but it makes sense in the sense of substituting whatever's in here is x, and that's x. Okay? So tell me now, what is f of x minus h? Write it down on your paper quickly, if you can. I'll circulate this quickly just to help be able to peruse every paper, but let's see. I just said it and I emphasize it again. Most people miss this, did it because they were thinking. Don't think on the substitution step, just substitute. Don't do anything with that thing you're substituting except substitute. Okay. And if you do that, what replaces x? X minus h. So you write x minus h. What am I missing? I'm missing the square. The whole x is squared, so the whole blamed x minus h is squared. Okay. I've seen x squared minus h. I've seen x minus h squared with no parentheses. I've seen a variety of thinking. We don't think at this step. Now we think after we do this, we got to expand that. How many think that's x squared minus h squared? How many think it's x squared plus h squared? How many think it's x squared minus 2xh plus h squared? Well, that's what it is. Distributed. We're going to talk about that in a minute. Okay, but let's just worry about the function notation. So, coming back to wherever in the world we wrote this down. Oh man, where is it? Get x minus h squared plus k. If h is 12 and k is 8, what did we get? You can write it out. Here you're going to replace h by 12 and k by 8, right? We get x minus 12 squared plus 8, which is what we got. This formula tells us how to get the formula. without thinking. But you want to think. And you want to think why this works. It's because x minus h is how far you are from the origin in your basic function. And when you square it, that tells you how far you got to go up. Okay. And that formula is a big deal. And there's more. There are a couple more formulas. I want you to understand that one. And I'll give you some problems to think about. They should be posted tonight, where you explain a few things to yourself and to me. Okay. Gosh, I was recording again. We got g of x minus 12 squared plus 8. And we want to look at this x minus 12 squared. Okay. Now, people want to say x minus 12 squared is x squared minus 12 squared. Or maybe x squared plus 12 squared is a negative. Okay. So the example 12 minus 5 squared is not 12 squared minus 5 squared. 12 squared is 144, 5 squared is 25. 12 minus 5 squared, you do what's in the parentheses and you get 7 squared and you get 49. That's right. And it's clearly smaller than what you have here. You don't even have to calculate to see that. Okay, so big no. A plus b squared is not a squared plus b squared. Okay. When you square something, you multiply it by itself, by the whole thing. You don't just pick up this and this. You know, this multiplies this, this multiplies this, this multiplies this, this multiplies this. You know that. So don't slip up. It's really easy to do, really easy. I think that ought to be x squared minus 12 squared or x squared plus 12 squared. You do that and you're dead in the water. Your graph doesn't make sense, your function doesn't make sense, nothing makes sense. I write this out as follows: x times x minus 12 minus 12 times x minus 12. This is the way I want to see you write it out. People are used to doing this. Right? That passes for the distributive law. It works. I still want to see it written out because I want to emphasize the use of the distributive law. Okay? Okay, so that's x times x minus 12 times x minus 12 times x minus 12 times minus 12. And, you know, I wrote down plus 12 squared. I want to be very detailed about this. That is x squared minus 12x minus 12x plus 144, which is x squared minus 24x plus 144. Of course, you got this formula that people memorize, but they never think about why. A plus b squared is what? Okay, it's a times a plus b times a plus b. Equals a squared plus 2ab plus b squared. If that isn't second nature to you, then either it's been a decade since you had algebra 2, or you weren't assigned enough problems that used that in algebra 2. Okay. You don't really need it, but it saves you a lot of time. You don't would have gotten this without having to go through all this. Still, we want to go through all of this. Now, my point is, then g of x equals x squared minus 24x plus 144 plus 8. And of course, we do one more step, we can add that 144 and 8. And we get this. Well, let's just assume this function here is important. Okay, that's a function we just did. That function has a formula right there. G of x is x squared minus 24x plus 152. Plug in x equals 13. 13 squared is 169. Add that to 152, you get 321. Yeah. Okay. And 24 times, what are you making me do these numbers for? Okay. Now 240 and 72 is 312. You subtract that from that number I said before, and you get 9. Okay. It works. I think I said the right numbers too. Listen to the video and prove me right or wrong. Okay. Let's say that I want to know what the value of x is when g of x equals 10. So here's the line y equals 10. If I've got a good parabola, I can make an estimate. Down here. And down here. Now this is 13. This might be 13.5. And this might be, well, if this is half a unit from this side, this should be half a unit from this side because of the symmetry. So that this should be 10.5. Understand what I just did? G of x function is 10 when x is here or here. Estimated 10.5 or 13.5. Okay, let's test it. Okay, we're recording it. Okay. And it's not 13, it's 10. We're going to solve g of x equals 10. The graph and make these estimates. Now it's just a slop down graph. I don't expect these estimates to be great, but they should be in the right ballpark. Okay, well. Better use a little algebra, and you know, you've probably forgotten so much that you've got to recognize it. G of x is this, so g of x means g of x equals 10 means this is equal to 10. Okay, so somebody identified this as a quadratic equation. Somebody made a very good suggestion, well, you can solve it by factoring. Yeah, but it's not going to work in this one. It almost never works on a real world problem. And so I don't really think, well, I think all this, well, never mind. Okay. So we have this. How do we use the quadratic formula? Quadratic formula says this, and I'm not even going to read it to you because everybody's seen it. Now, key, since we have just a minute left, to using the quadratic form, and this should be review something you once knew. We have to put it in this form, which means you've got to have 0 on this side. You've got to subtract that 10 from both sides. You know that. You might not remember it, but you know it now, right? Familiar to you? Yeah. Okay, well, 152 minus 10 is easy. Okay. Now, show me with your fingers, what's the value of A? One. A is the number in front of x squared. There isn't a number in front of x squared, so it's automatically 1, right? A is 1, B is negative 24, C is 142. We plug it into the formula and we get a number. We get 2 numbers, one for the plus, one for the minus. Those numbers I claim are going to be reasonably close to 13.5 and 10.5. Well, reasonably close. I mean, it might be, 13.2. Well, 13.8, whatever. Okay. Could be off on that 0.5. That's just a ballpark the way my graph looked. It wasn't precisely drawn graph. Okay. So look to the assignments page for your assignments. Everybody knows where the assignments page is and has a bookmark, and everybody knows where the videos have been. Am I correct? If I'm not, stick around and let me explain it to you, okay?